Hi, we are the team 5 and we are going to make the demonstration of the formula of the distance, right, point. Well, we are going to start.
Well, first our formula is this, and we know that our line 1 is ax plus by plus c equals 0, and our point is x1, y1. So the first step is to find the perpendicular line. First we need to pass the line 1 to standard form, and we get minus a over bx minus cb. And from that we can get that the slope is a over b. And since the slope of the perpendicular line is reciprocal, then we get that the slope of the perpendicular line is b over a. After that, to get the equation, we use the point slope formula. Since we know our slope, we just substitute it, so we get y minus y1 equals b over a times x minus x1. We solve and we get y minus y1 equals b over a x minus b over a x1. And then we isolate x and we get y equals b over a x minus b over a x1 plus y1. And this is the distance, the formula for our perpendicular line. So our second step is to get the intersection. For that we need to equal the line 1 to the line 2. Our line 1 being the original one and our line 2 being the perpendicular line. So we equal them. Then we pass the x's to one side and we get these. Then in order to make it positive, we multiply everything by minus 1 to get the positive result. Then we factor x on this side and we get x times a over b plus b over a equals the equation. Then we isolate x by passing these dividing to the other side and we get this. And then we need to solve each side. So on the top side, our common factor is av. So we just solve it, and on the downside the same. And we get that x equals b squared x1 minus av y1 minus ac over a squared plus b squared.
Okay, so now we're getting the intersection for y by substituting x in the equation of line 1. So we substitute x by what we got in the past step, and then we solve this, and we solve also with this, and once we have this, we can cancel the a squared c, positive and negative, and once we've got this, we can eliminate the v's because it's multiplying in the denominator. And when we cancel the b's, we have our final result: y equals minus abx1 plus a squared y1 minus bc over a squared b squared.
Now the third step is finding the distance between point x1, y1 and point a, which is x, y. We know that our x is this and our y is this, so we just need to substitute. We substitute the x, which is this one, minus x1 according to the formula, all to the squared, and the y, which is this one, minus y1 all to the squared too. Then when we solve the equation, x1 turns to be minus a squared x1 minus b squared x1, which you can cancel the b's. And on the other side, the y1 turns to be minus a squared y1 plus b squared y1, so you can cancel the a's, and it ends up like this. Then we factorize the equation, so we can get minus a times by1 plus c plus ax1 all over a squared plus b squared into the squared. And from this side we can factorize the b, so we get minus b times ax x1 plus c plus by1 over a squared plus b squared all to the square.
Well, now since we know that minus a to the squared is a squared, we can now factor a squared times the equation plus b squared times the rest of the equation again. So we can make the a squared plus b squared
A common factor.
common factor, and we put it times the rest of the equation. We can cancel
The a squared plus b squared over the a squared plus b squared, and we left with ax1 plus by1 plus c squared over a squared plus b squared. And since we know that square root of x squared equals absolute value of x, we can get now the final formula.